Okay, this is Unit 2, video number 2. We're looking at models of the atom in this video. First off, we're going to look at the current model of the atom just to give it a name. In the current model of the atom, we refer to it as the electron cloud model. It has other names. They're more sophisticated. We're just going to leave those. In the current model, protons and neutrons are held together in the nucleus. In the first section, in the first video, we talked about this. Protons and neutrons are in the nucleus. Electrons in this model of the atom occupy a large volume outside of the nucleus. These electrons move around the outside of the nucleus, and they're moving at such a high speed that if you could see it, it would look like a cloud. It's kind of a blur. That's maybe where the name comes from. And this is, of course, if we could see it with our eyes. Looking back in history, the first person to return to this idea of the atom was a man named John Newlands. So remember, we had Democritus. He suggested the atom, and nobody else went with it. Fast forward about 2,000 years, approximately, John Newlands. He believed that atoms existed as solid spheres, maybe something like a marble, and that atoms of each element had its own unique chemical properties. He hypothesized that a chemical reaction rearranges atoms rather than just having chemicals that change identity. It's a new idea. So here's what he's doing. Dalton is recording the masses of products, reactants, getting ahead of myself. He is recording the masses of reactants, which are chemicals before the chemical reaction. And then after the chemical reaction, he's comparing that to the mass of the products, the chemicals that are after the chemical equation. Terminology here is actually pretty simple. Reactants will react and products are produced. The recorded mass of reactants and products were equal. Observation that he found. Based on the data in his experiments, his hypothesis is that atoms are rearranged in chemical reactions. Atoms are rearranged. So he's got these solid spheres. So let's think of them like marbles. You've got some marbles, and there's a few marbles put together in one, a few marbles put together over here, and you bring the two together, rearrange the marbles, and then separate them. And now you have two different sets of marbles. And that's maybe the idea. Next model of the atom was created by J.J. Thomson. Thomson is responsible for the discovery of electrons. So his model of the atom, we have a positively charged solid sphere. And we have negatively charged electrons that are just distributed around the surface. And so for a picture of this, here's our solid sphere, and this sphere has a positive charge. So I'm going to put 4 positives here. So the solid sphere is positive, and then there are electrons distributed around the surface. So here's an electron, it's negative. Here's an electron, it's negative. Here's an electron, it's negative. And one more. The numbers of positives here equals the number of electrons. This is an old model of the atom, and it is known as plum pudding. So plum pudding is a dessert not common in the United States. Seems to be an English thing. Around Christmas time, plum pudding is a dessert, and I don't know, you can look up pictures of it. It looks strange. It's like some sort of a custard that was baked until it was somewhat firm, and it's got a lot of little pieces of plums in it. It looks kind of like a cake with a bunch of raisins thrown in it. Maybe a better modern comparison is that it might look like a chocolate chip cookie. The cookie part would be this positive mass, and then the chocolate chips would be these negatively charged electrons. So Thomson was doing some experiments. He had a device called a cathode ray tube. When I see you in class, I will get out something that I have that is a cathode ray tube, and we'll go through what's going on with it. A description here: this device is a sealed glass tube with the air removed to create a vacuum. Think about maybe a light bulb where they pull all the air out of it, maybe something similar. An electrical current is sent through the tube, producing a visible stream called a cathode ray. So first, let me draw a basic picture. So here is the tube. This is an electrode. This is an electrode. So let's label these. And make it look like a real circuit. Here's a switch. Here's a power source, and we connect it. So basically you've got a battery, a switch, and this cathode ray tube. Here's the tube, and once it is powered on, make this a different color here. Once you close the switch and give it power, you start to see this cathode ray appear. So like any good scientist, he's going to figure out ways to experiment with this thing. And so what he comes up with is, I'm going to draw a smaller scale of the same thing without labels. There's the electrodes. There's the power. And this time he's going to do something different. He's going to hold a magnet here. I've got a demonstration for you, kind of like this. So holding a magnet here, he notices that when he points one side of the magnet towards it, the cathode ray is pushed away. And if he were to flip the magnet the other way, the cathode ray might be deflected this way. So, interesting thing that happens is it changes the direction of this visible beam with a magnet. So holding a magnet near the tube would cause the cathode ray to change directions. So Thomson is measuring it. He's measuring the effects of magnetic and electric fields. And he concludes, first off, that electrons are a thing, they exist. And through some other experiments, he figures out the size. He says that they are much smaller than a single hydrogen atom. So a single hydrogen atom, something that we'll talk about soon, is that a hydrogen atom, maybe we could write it like this, has 1 proton, 0 neutrons. So basically, we're talking about a single proton. Electrons are much smaller than a single hydrogen atom. Electrons are much smaller than a single proton. Thomson wins the Nobel Prize. He discovered the first subatomic particle. The first particle that is below the atomic level or smaller than the atom.